Hi, good evening. Hello. Hi. Hello. Shall we wait for a few minutes? Hello. Hello, this is Balaji. Can audible this? Hello.
Yes, sir, audible.
Yeah, okay. We can wait for 5 minutes. Okay, someone will join there. Okay. Huh?
Okay, sir.
Okay, sir.
Thanks. Slide is audible. Sorry, we can able to see the slide.
Yes, sir.
Okay. Okay. We'll wait for 5 minutes. Hi, learners. We will wait for 5 more minutes. Let them join. Okay, learners. We will start the session. Okay. This is Balaji from NIT Tiruchirappalli, PMR scholar. I am a TA for Professor Sonak Kumar Chaudhary, who is handling the manufacturing process, casting and joining. Right. This is in the second week. Last week we will solve a couple of problems, like nearly 10 problems we solved with a little bit explanation also we solved. This time there will be a two TA will be there. One is Mukesh, another one is me. I think last Saturday you solved 5 problems from the assignments. The next five problem I will solve. Before that we will see some detailed about the topics. What are the topic we are going to be see the problems? We will see that before. Okay. It's audible, right?
Yes, sir.
Yes, sir.
Okay, okay. Right. This is in the four topics we are going to solve the problem there. Before solving the problem, we will see some introduction and some explanation also for the four topics we will see. Okay. First one is solidification. Second one is Chernobyl rule, and third one is solidification of shrinkage, and the fourth one is gating system. Right. In the fourth problem, we are going to see we are going to solve the problem at the same time. We will see about some introduction and the detail also we are going to see. First, the solidification. Okay. In solidification, there will be it is a phase transformation from the liquid to solid state. Is a phase transformation will be there. Okay. We can be able to explain from the cooling curve of the pure metal. First, we will see about the pure metal. Then we will see about the alloy also. Right. This is a cooling curve between the temperature and timing. Okay. This is a cooling curve. It is a temperature and timing. Okay. From here, we will going to start with here. The metal is molten metal will pour in the casting, then he will be in a temperature will be constant for some time because it will be in a liquid stage. Then in the liquid stage itself, it will start to the cooling. Okay, in this will be in the form it will be taking the cooling take place. Right here, the temperature drop will be there at the same time. The time when the timer is increasing, at the same time temperature drop will be there. But still, the molten metal will be in a liquid stage. Still, the molten metal will be in a liquid stage. That is in a here it is when it is temperature is getting drop at the point itself the solidification time is started. Okay, in this point itself the solidification time is started in the point itself. Okay, then the temperature drop will be there. Okay, temperature drop will be there up to the freezing point, up to the freezing begin point. Okay, till the point the temperature will be drop will be there, still it will be in a liquid molten metal will be there. Okay, from after this the freezing point is going to start, then the local solidification time will be start. Okay, from the where the freezing this point is getting begin, from the point itself the local solidification will start. Right, then the temperature will be in a constant. Okay, temperature will be in a constant. Here the phase transformation will be there. Okay, little bit here will be in a from here to here there will be in a, some density changes will be there. Okay, the density change will be there. Then still now it will be in a liquid stage. After when the freezing point is started, then it will then it will be start to freeze. Okay, then the start of the freeze, then it is changed to solid. Here will be the density will be changed, at the same time the temperature will be in a constant. Okay, temperature will be constant, the time will be varying. In this point the freezing point will be completed. Okay, completely it will be in a solid state. Completely it will be freezed. The phase will be changed as a solid. Okay, after this point it will be the solid will be again the cooling will take place. Again the cooling will be take place after the freezing point. The cooling will be take place. Okay, here the temperature drop will be there up to the ambient temperature. Up to the ambient temperature, in the ambient temperature, up to the ambient temperature the cooling will be taking place. Then it will be in a full of solid will get. Okay, this is a cooling curve for the pure metal. Okay, in the pure metal the freezing point and the melting point will be in a same. Okay, the freezing point and the melting point will be same only for the pure metal. Right, only for the pure metal. The next one. Right, now the cooling curve for alloy. Right, before we seen about the pure metal on one point I told when it will be in the freezing point and the melting point will be in a same. Right, in a cooling curve for the alloy. Okay, in the cooling curve when the solidification is happened, right, at the time same thing it will be in the curve the graph will be in between temperature and time. Here the molten metal pouring in the casting. Okay, and it will be here it will be pouring temperature will be there. Okay, then the cooling will take place. The cooling will take place and the temperature will be drop will be there. Okay, temperature drop will be there. After that there will be in a pure metal the freezing point the freezing begin and completed will be in a total it will be in a constant. The temperature will be in a constant. Here the temperature won't be in a constant. Okay, keep on the temperature variation will be there. Okay, keep on temperature will be there, but here at the when the freezing point is begin, then it will be the phase changes little bit will be changes will be there. Okay, and when it is freezing completed, it will be in a full of it will be solid. Okay, still the temperature will be maintained. Then after that it will be cooling to take place, then it will be in ambient temperature. See, this is a graph for liquid and solid state, or for the nickel and copper, right? This is nickel and copper. The one first curve, there will be two curve will be there. The L and S is the mixed portion will be there, liquid and solid. The in between is the liquid and solid phase will be there, right? The top portion will be the liquidous line, then the lower portion is the solidus line, right? The solidus line is nothing but below the solidus line it will be a solid. Okay, below the solidus will be a solid. The above the liquidus line it will be a full of liquid. It will be above the liquidus line it will be a liquid. Okay, in between line there will be a phase will be two phase will be there, the liquid and solid, liquid and solid. See, when the freezing point started, when the freezing point begins, see, this is a liquidus, right? This is a liquidus point, it will be in a end, then it will be a liquidus, it is a point, then it will be start to solid, so it is started to solidification. Then see the second, when the freezing point is completed, see the point, it will be completed to be in a solid. Okay, it will be completed to be in a solid, right? But in a cooling curve, for the pure metal, it is completely in a constant temperature. But in alloy it won't be in a constant. The temperature vary will be from the freezing begins to completed, right? This is a example graph for nickel and copper, right? Second, next one, we have now we say about the solidification, right? Now we have to see the solidification time, how much time it's taking for a solidification for the one block or rectangular or square or sphere, anything. Okay, the mold will be in a rectangular or circular or sphere, anything is there, but how much time it will take to solidify. Okay, that is the Churner rule it is. Okay, in the Churner rule it will be depends upon the volume of the mold, at the same time the surface area of the mold. Okay, it will be a relation between volume of the mold and the surface of the surface area of the mold. Okay, then the B is the constant of the metal. The B is the constant of metal, and the T is the solidification time. The B, the constant of metal, it will be it will be vary upon the mold material and the casting condition. Okay, it will be vary upon the casting mold and the condition. Right. And then the exponent will be vary. When I told now it will be in a sand casting or metal casting or any other, it will be changed between 1 point. The exponent will be changed 1.5 to 2. Okay, it will be changed. It depends upon the material. It will be changed. And critically, mostly we will use as a 2. Okay. Then there will be in a, see, the metal constant is there, and the metal constant, how it is depending on the solidification time. Okay, the metal constant is depends upon, right? One is the mold material. Okay, what is the, it will be depend, it will be vary it depends upon the sand and the metal, molten metal, it will be vary, depends upon the mold material. One second one is the thermal property of the casting metal. Okay, the thermal property depends upon the each and every material, the thermal property will be different. Next, hello,
नहीं है सर.
hello, hello, any question is there, any doubt?
Sorry sir, no
Okay,
sir.
okay. Then third dependent one is pouring temperature. Okay, the pouring temperature will be there. These three of them depend upon the mold constant. Okay, the three are depend on mold constant, that is B. Mold constant nothing but it is a B, one is a mold constant, right? Okay. Next one. Okay, solidification of shrinkage. Okay, this is the main parameter in the casting. Okay, the solidification shrinkage will be there. Okay, it will be occur nearly for all the metal, there will be shrinkage will be there, because there will be the main principle is the solid phase has a higher density than the liquid phase. Okay, the liquid phase, the density will be very low, and the solid phase is having a higher density, right? When we are pouring a molten metal into the cavity or molten mold, okay, it will be in a liquid stage. In the liquid stage, there will be high temperature will be there. In high temperature, all the molecules that will be in a expand from the grains. Okay, the grain will be expansion will be there. All the molecules will be expansion will be there. Okay, when it is getting cooling, when it is getting the solidification, okay, at the time there will be in a cooling curve we seen, right, when it will be freezing point and it will be to the cooling place will take place. At the time the liquid will be changed to solid. That means the less density to it is getting into a higher density. Due to that there will be a contraction will be there, okay, in between there will be a contraction when there will be a more heat will be there will be an expansion will be there. When you are going for cooling, the solidification, there will be a contraction will be there. That is called a shrinkage here, okay, right? And here see the solidification shrinkage causes a reduction in volume per unit weight of the metal. See, when it is pouring a molten metal into the mold, okay, here pouring a molten metal into the mold due to liquid contraction. See, the second one is here the molten metal pour in the mold. See here that will be reduced due to shrinkage. This shrinkage is called liquid contraction. Okay, when we call this in a liquid contraction means in the mold, see, the molten metal fully it will be in a liquid stage. Okay, the molten metal fully it will be in liquid stage. The skin alone got solidified. Okay, the skin alone got solidified. Right? This is called as in a liquid contraction. Okay, it's called liquid contraction. Then see the next one. See, due to solidification of shrinkage, due to solidification of shrinkage, it will be happen. Okay, see the height of the molten metal will be reduced. Okay, where we poured here full to the end. Here it is, see, it is it reduced, the shrinkage is happen. See, but still there will be full of solid. It is changed. The phase is changed, except the little bit smaller one. Okay, it is in a solidification shrinkage. Here it is a molten metal is there. Here is a liquid molten metal, but around all it will got on a solidified. Right? See the last one. See the last one, completely it is solidified. Okay, it is completely solidified. See, there will be it is in a pipe hole will be there. The defect is called in a pipe hole. Okay, this defect is in a pipe hole. At the same time, see the around all the volume side is got on a shrinkage is happen. See, there will be in a positive shrinkage it is called. It is called as in a positive shrinkage. Okay, how we can give, we want to avoid the shrinkage, we have to go for a positive allowance. Okay, we have to give a positive allowance for the shrinkage, right? See, due to the thermal contraction, this defect is called as the cavity is raised, it is called as a pipe hole. Okay, it is a pipe hole defect. At the same time, see around all it will got on shrinkages happen. Okay, to avoid this, we will go for a positive shrinkage. We will go for positive shrinkage. Positive shrinkage means nothing but see, if it is, see, it is in a mold. Okay, now the mold, it is the dimension is 10. Okay, now we have to exact 10 mm we have to need means we have to given a positive allowance. Okay, we have to given a positive allowance for the positive shrinkage allowance. Okay, we have to given a positive shrinkage allowance. That means the mold should be, okay, the mold should be like a 0.5 mm, 0.5 mm we have to give an allowance for this, 0.5 mm, 0.5 mm. Okay, the allowance on the both sides should be, the allowance on the both sides should be 0.5 mm. Okay, the allowance on both should be 0.5. 1 mm we have to give an allowance for that. Okay, then your mold should be as 11 mm. The mold should be as 11 mm. Then we will get an exact 10 mm we will get. Okay, this is a positive allowance. Okay, see the next one. See, if we are going for cast iron with a high carbon content, the shrinkage will be won't be there. Okay, when we are going for cast iron, the shrinkage won't be that much. When you compare for other material, for aluminum, copper or anything, okay, it will be in a shrinkage will be more, except the cast iron or the gray iron. Anybody can able to know why the reason? Anybody? Why it is only in a cast iron the shrinkage would be very less. At the same time, the gray cast iron also would be very low. Why? Anybody? Hello?
Yes, sir. I want to tell. Hello.
Tell me, sir.
Because cast iron has graphite flakes,
Yeah,
and
yes, sir. Tell me, sir. Tell me, sir.
and yeah, yeah. When the cast iron solidify from liquid to solid,
Okay.
the graphite flakes tends to expand rather than compression.
Compared to other material, exactly, it is correct, sir. It is correct one.
Yes.
See, sir, in a gray cast iron, see the carbon present transform into the graphite flakes. Okay, during the liquid, the solidification shrinkage will be there, right? Say the skin will be there, right? The skin it will be in the form as a graphite, transformed into graphite, and the form as in a pore. Okay, this is in a porous. It is full of it is in a porous graphite porous. It is okay. Therefore, it will show to the expansion rather to the contraction. Okay, now all the metal there will be a contraction will be there, but alone in a cast iron and a gray cast iron, there will be in a thin layer will be formed, the skin will be formed. Okay, it is nothing but it's a graphite flux. It is full of, it is porous. It will be expansion rather the contraction will be there. Due to this one, there will be in a negative elements will be there. Okay, in the shrinkage elements, in the gray cast iron, we have to given a negative. Here instead of you given us 10 mm, right, we have to go for 9 mm. Okay, the mold should be for graphite, the mold should be 9 mm. The mold should be 9 mm. 1 mm we have to given a negative. Okay, 1 mm we have to given a negative for only for the gray cast iron, only for gray cast iron. Okay, only for gray cast iron it is the negative elements only for gray cast iron. For another, for all the material, it will be allowance will be in a positive. Okay, but in the cast iron also it will be positive only, but not that much. Okay, we can given us here 0.5 we giving means we can give us in a 0.25. Okay, clear. The next, the last one is a gating system, right? The gating system, we are going to see about the two gating system. One is in vertical gating, another one is in bottom gating. Okay, there will be two gate system will be there. One will be in a vertical, another one in the bottom will be there. In the vertical gating system, it will be flow due to account the atmospheric pressure will be there in the top layer. At the same time, gravity, due to gravity, it will be flow, it will fill the mold. Okay, due to gravity, it will fill the mold. Right, in atmosphere, due to atmospheric pressure, the pressure will be in the top, it will be atmospheric pressure will be there here. And then due to the atmospheric pressure and then the gravity, it will fill the mold. Okay, then it will be fill the mold. Right, now
Excuse me,
HT
sir.
equal to root 2 GH, no sir?
yes, I will explain, sir. I will explain. I'm coming.
Excuse me, sir.
Tell
So
me, sir.
someone want to join the class.
Yeah, wait. No one is there, pa? Yes. Yeah, admitted. Yes. Now the gating system. Here we have to calculate the what is the velocity it is flowing in the mold. Okay, we have to calculate the velocity, right? For to calculate the what is the sort of filling time the mold due to vertical gating and the bottom gating. We are going to calculate the what is the time to fill the mold. Okay, here we have to we're going to calculate to fill the mold how much time it will take, right? Now we will see the how the derivation is formed. There will be no energy equation will be there. Okay, this point and this entry point and there will be an end point is there, right? Here we have to write an energy balancing equation. Energy balancing equation nothing but whenever you're going for a flow or something, right? And then fluid mechanics, there is a Bernoulli's equation is there, right? You know about you cross the Bernoulli's equation, you cross it, right? The Bernoulli's equation.
Yes sir, yes sir.
Yeah, P1 by
So
see?
pressure 1 and pressure 3
Yeah.
are is equal in this Bernoulli.
This is in a head it is. Okay, first one is in a head it is in a pressure energy P1 by rho and plus V1 squared per 2G is in a kinetic energy. Then
One is
F1,
atmospheric pressure and
yeah,
third is the open.
yeah, and then F1 is in a friction it is. The F1 is in a friction, right? In this case, now we are going to here it is formed the Bernoulli's energy balance equation for 1 and 3. Okay, the 1 and 3 we form in a Bernoulli's equation, right? It is in a the first one it is in a top layer is one. Then second one, the last one is the end of the mold, right here. Now,
Yes sir, yes.
yeah, excuse me, any queries is there?
No sir.
Oh, okay, right. Now you see the pressure will be here, we are the atmospheric pressure we are make it as a 0, right? At the same time density also we are not considering, right? Then V1 squared will be in a, see here in the top layer there is no velocity will be there, then also it will be in a 0, then it will be 0, then the friction also we are eliminating it, right? Then the H3 it is in a datum is in a 0, this is all in a 0, and the pressure in outside is also in atmosphere, then it's all in a 0. Okay, then friction also it will be 0. While simplifying the V3 square by 2G plus here an HT is there, right? We will simplify, we'll get an equation, right? This is in a velocity of here, the third one, root 2G HT, right? It is in a root 2G HT, right? G is nothing but a gravity it is, right? Now the filling time. Now the filling time normally the filling time will be it is volume by discharge. Okay, it is now volume by discharge. It is volume by Q. Q we can able to write as area and velocity, right? You can write this one here. There's a then there's a filling time Tf is equal to V divided by there is a gate area and it is in a velocity, right? It is a volume by area and velocity. It is in a filling time. This is a Tf is equal to V divided by Ag by F. This is the formula to calculate uh, the filling time in the mold. Okay, in a vertical gating system, right? In a vertical gating system. Just a minute, someone is waiting. Right, right. The next one is, any doubt is there in a gating system, in a vertical gating system? It's okay, right? It's clear. It is audible. Hello.
Yes, sir.
Okay.
Yes, sir.
Okay. Next one. It is in a bottom gating system. Okay. It is in a bottom gating system. It is in another one is type of the gating system, right? In a bottom gating, see in a previous one, there will be a vertical will be there. See, I told you it is in a full of atmospheric pressure and then gravity. It will fill the mold. Okay. The second one, it is in a bottom gate. Okay. Due to the atmospheric pressure, here it is in a flow on the gate, then it will be in a horizontally it will be fill the mold. Okay, it will be horizontally it will be fill the mold. Okay, it is in a bottom gating. This is in a gate. It is in a gate. Due to the bottom gating, it will be due to the screw it will enter into the mold. Okay, it is fill the mold. As same thing, we have to go for an energy balancing. First of we are going for 1 to 3. The energy to find the TF, that is filling time. To calculate the filling time, you have to calculate the equation for both balancing equation. You have to do for 1 and 3, then 3 and 4, right? First energy balance equation. Here I simplified. Okay, in the previous one I written fully. Here I simplify. And after simplifying, what we will get is the first equation for in between the balancing equation 1 and 3. Okay, in 1 and 3, here I previously I told all the pressure and velocity will be in a 0 in an atmospheric pressure, right? In the 3 it will be in pressure and velocity. I asked and I eliminating the head and friction I eliminated, right? The next one, the fourth one, third and fourth, the balancing equation for third and fourth. To simplify this one, we will get a second equation for the balancing equation. First is 1 and third, then third and fourth. Okay, right? By equating the both equation, you will get the velocity in the mold. Okay, H is gate velocity. It is root of 2g ht minus h. Okay, this is ht minus h. It is okay. It is the velocity of the bottom gating. Okay, in vertical gating, simply written as v is equal to 2g ht. Okay, right? Can you put on mute? Hello. Mute it, man. Okay. Next step. Then we have to go for here 3 and 4. There we have to go for a continuity equation. Continuity equation is a1 v1 equal to a2 v2. Okay. Then we have to equate with the whatever they're getting equation from the velocity equation. We have to equate with the continuity equation. Then we go for integration for 0 to TF, the time filling. Then we have to integration. Finally, we will get an equation like this. It is in a bottom gating. Okay, it is in a bottom gating. Okay, now I have no questions. Which one will fill as soon as possible, whether it is in a vertical gating system or bottom gating system?
Vertical gating system.
Why? Reason?
Because time of filling is less in it.
Yeah, because it is there is no need to pour into the gate. See the second one, if you want to fill the gate, then you have to cross it. Okay. Okay, then it have to fill the mold. Okay, time it will take. Okay, it will be 2 times faster. Okay, it is a bottom gating system. It is very 2 times slower than the vertical. Okay, the vertical gating is 2 times faster than the bottom gating system. Okay, the vertical gating system is 2 times. Okay, 2 times faster than bottom gating system, right? Now any advantage on that? For what is the advantage for bottom gating system? What is the advantage for vertical gating system? Why need to go for bottom? Why need to go for vertical?
Sir, because in vertical gating system, we can find turbulence
Yeah.
while filling the mold.
Yeah.
And in bottom gating system, there is less turbulence, or we can say there is no turbulence.
it is correct. Okay, when we are going for a vertical bottom theorem, there will be a turbulence form. Due to turbulence, the erosion will be there. Sand erosion will be there. Okay, in sand erosion will be there. But in a bottom getting system, we can avoid the turbulence. Then the erosion will be won't be there. Okay, but erosion, the only one advantage in the bottom getting system. Okay, in the bottom getting system, the another one more disadvantage is there. Okay, it will be in as while solidifying, here will be in a clock will be happening. Okay, solidification clock will be there. Okay, uneven solidification will be there. Okay, to reduce that we have to go for chill and chaplet and all. Okay, this is a very complicated one. Okay, the bottom getting system, here after here there will be no solidification time will be solidification will be there, uneven solidification will be there, here and all clock solidification will be there. Okay, in a vertical getting system it will be in a very easy, then gravity it will be flow, here and all we need to give some pressure on the, but in a vertical it will be flow easily. Okay, but another one is here will be some oxidation form will be there in vertical gating system. Okay, we have to, there is no cover and all will be there, but in bottom gating system there will be no oxidation we can be avoid. Only two things, one will be in erosion and oxidation can avoid in the bottom gating system. Then the vertical gating system, it will be totally, it will be more advantage will be there, because it will be opened and fast fast filling. At the same time there will be an only one disadvantage in erosion will be there, only one disadvantage in erosion will be there. Okay, keep in mind it will be in a bottom gating system 2 times lesser than the fast will be there. Okay, in a vertical gating system it will be 2 times faster than bottom gating system. Now, okay, now we've seen about all the introduction we've seen about and detail we've seen. Now we will go for a problem session, right? Okay, first one, the steel rectangular plate of 5 centimeter and 8 centimeter and 2 centimeter has to be casted. Okay, the total solidification time of the casting is 1.2 minute. Okay, the 1.2 minute. The mold constant in a minimum minute per centimeter square for such a mold would be. Okay, they are asking the total solidification time. No, they are asking for the mold constant, the B they are asking. Okay, go for the rule is there, na? Okay, Chernow rule is there, na? You apply this and calculate the B1. The B is a mold constant. Okay, the B is a mold constant. Okay, try it. Now try and tell the answer for that.
Sir, please show the question.
Yes. Just calculate the B1, B, the mold constant. Okay, total solidification time TST equal to B into volume divided by surface area the whole square.
Sir, 0.6 it is coming, sir.
Surface area is correct for you, 132 centimeter square surface area, and the volume is 80 centimeter cube. Use Chernow rule, apply in the equation. You got the same?
No, sir.
Yeah, try it. The solidification time is given, 1.2 minute is given, the T is given. You have to calculate the B, mold constant.
Sir, 0.3 millimeter per centimeter square.
No, not millimeter, minute. 3.2
Minute,
minute per
yeah.
centimeter square.
0.3 minutes. 0.3 minutes per centimeter square.
Yeah, it's correct, sir.
Sir, N value, what?
I told 2, sir. I already told 2. say if the n value is not given, particularly say they are using in a different material, the n values they will give. Okay, if the n value is not given, we have to assume as a 2. Already I told now. When I taken the Churner rule, I told. Okay, if n is not given, blindly we can take as a 2. Okay, you understood? Clear?
Yes, sir.
Okay. All are got it? All are getting a 3.268 or 3.3 minute per centimeter square. Right. We'll move for the second one. Right. The second question, the solidification shrinkage occur in nearly all the metal because the solidification shrinkage occurs in nearly all metal because which one it is from the 4?
Its answer must be B.
B. Anyone? Any other answer? Any other answer is there?
Yes, sir. B is the correct option.
Yes, sir.
Yes, B is the correct one. Okay, because the solid phase has higher density than the liquid phase. Okay, and the solid solidification itself I told the solid phase has higher density than the liquid phase. Someone is waiting. Next. Okay, the third one. The ratio of the time to fill the mold cavity with the bottom gating and the time to fill the mold cavity with the vertical gating system. It will be
A, sir.
A, right? I told her. Okay, the vertical gating system is faster to fill the mold 2 times better than the bottom gating. Okay, right? It is faster means the vertical gating system is the faster one. It is. A's answer is 2 times faster than the bottom gating. Okay. The next one, the mold constant in a Chornak rule depends on the mold constant. I am asking about the B, the mold constant B. It depends on.
सर इसका सर मोल्ड मटेरियल, थर्मल प्रॉपर्टीज और पोरिंग टेम्परेचर, मतलब फर्स्ट 4 और 6 वाला.
Any other answer? Any other answer? One I got answer. One is in the first one, and thermal properties and the pouring temperature. Anyone other answer is there? Any other answer? Right. See, the mold constant of a Chennai rule already I told when I taken the rule itself. It will be depends upon the mold material. Okay, depends upon the mold material. It will be changed. Different mold material will be changed. At the same time, thermal property of the cast, thermal property of the casting depend upon the material. It will be changed. Each and every material having a different thermal properties. Then the pouring temperature. The pouring temperature also depends upon the material. It will be changed. For example, for aluminum it will be 650. For an mild steel it will be 1449. Okay, depends upon the pouring temperature also it will be differ. Okay, given the mold material, see the mold constant in the Chernok rule, that is the B. They are asking about, see what is the Chernok rule? It will be T S T equal to, there will be a P constant. This is a mold constant will be there. All right, then it will be divided by what will be volume by surface area.
Surface area.
Over the exponent. Okay, the exponent is it will be depends upon the material. If the material is given, means the n will be changed. Okay, the n will be changed up to 1.52. It will be 2. Okay, if it is not, they are mentioning about the material. They are not giving any material and all. If you blindly, we can able to take as 2, n equal to 2. Right? Clear? It's clear, right?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Next one. The last one, right? The flow velocity. The flow velocity of the molten metal at the base of the vertical sand mold. Okay, the base of the vertical sand mold is 108 centimeter per second. 108 centimeter per second. The sprue height in mm is they are asking about the sprue height. Any idea? Right? See, this is a sprue. Okay, this is a sprue. It is filling the mold, right? They are asking the what is the height. They are asking about the what is the height of the sprue. Okay, it is filling. The v is given, the velocity is given. The velocity is 108 centimeter per second is given. Okay, then the gravity also given. Be aware in the unit. Okay, in the unit is given as in mm. 9815 mm per second square is given. Okay, we have to convert it into centimeter because the velocity is given in centimeter per second. Okay, the velocity is given in centimeter per second. Okay, right? Velocity is given centimeter per second. You know the formula, right? V is equal to root of 2gh. Okay.
Sir, 5.94 centimeter.
5. Any other answer? Any other answer?
So,
All are getting 5. Any other answer is there?
sorry, sir, 59.42 millimeter.
Yeah, correct. 59 mm. Okay, in
Yes, sir.
centimeter means it will be 5.9. Okay.
Yes.
Yes. They are asking in see sir, okay, carefully you have to listen the question. See, they are asking in height in mm.
Okay.
Yeah, see the height is they are asking in mm. Okay, we have to
Earlier I had told in centimeter.
Centimeter, yes. So they will confuse you. Oh, see, the velocity is given in 108 centimeter per second. The screw height is they are asking in mm. At the same time, the gravity also they given in mm per second, right? Actually, it should be in meter per second square only. Okay, they are to confuse. They given in mm per second. Then centimeter second also. They play within a 2 unit. Okay. See, the velocity formula is v is equal to root of 2gh, and the velocity is given 108 centimeter per second, and here the gravity they are given as in 9815 mm per second. Okay, I converted into centimeter, right? I got an h equal to 5.9 centimeter. They are asking in mm. Okay, it is 59 mm. Clear?
Yes, sir.
Before before going the solution, write just read out the question 1 or 2 times. Okay, then easily we can identify what they are asking. Okay, if you are seeing a question itself, we can able to you can think okay, easily we can solve v is equal to root of 2gh. Okay, then the test will be the unit will be okay, right? Clearly even if you know the answer also, we can able to solve the answer also 1 or 2 times. You have to read the questions. Okay, first understand the question, then you go for the solution, right? Any other doubt is there? Any other doubt?
No doubt, sir.
Okay, in today we cross the solidification, Churner rule, solidification shrinkage, and the gating system. At the same time, the numerical problem also solved, right?
Right, sir.
Right. Any other doubt is there? All are clear?
Yes, sir. Clear, sir.
Okay, if you have
सर एक
any,
बार सर थर्ड वाला क्वेश्चन दिखा दीजिए.
so I don't know Hindi, sir. Can I speak in English?
Sir, will you show the third question?
Third question. Yeah, I will. Sure. Yeah, third question.
Done, sir.
Okay. See, if you have any difficulties to solve the problem in assignment something means you can ask freely. Just a mail me. Okay, this is my mail ID. Okay, this is my mail ID. Ask freely. Okay, just don't feel anything. Okay, free to ask, right? Just drop a mail on that. Okay, I will within one day I will reply for you, right?
Okay, sir.
Okay,
Thank you, sir.
thank you, man. We will see in the next session, right? Next Monday we'll see, right?
Yes, sir.
If you have
Thank you, sir.
any doubt means you can ask in the next session.
Okay, sir.
Okay, clear, clear,
Yes, sir.
right?
As a one question is there.
Yeah, tell me, sir.
Sir, can you please tell me how can I get PMRF scholarship?
So now what you are doing, sir? Now
Actually, I have completed my BTech.
BTech. Then you have to. What about doing in MTech now?
No, no, sir, I am not pursuing MTech. I am preparing for government exams related to engineering.
Okay, nothing, sir. Sir, if you just you have a gate score, you have a gate score.
Yes, sir. My GATE score in 2020. After 2020, I did not appear in the GATE exam. And last score was 2020, and the score was 467.
What is the marks for 100?
Marks were 43 point something, 43 point something, and I am from mechanical science.
Okay, so no problem. Now we have to just you want to complete a MTech. Okay, due to gate score, we can able to join an stipendary institute is there. Okay, stipend institute is there. You have to join an MTech, and then you have to complete a MTech. Then you have to, if you want to do a PhD only, the PMRF is eligible for you. Okay, in otherwise if you are in a MTech, if you are in a BTech, direct PMR also we can go. Direct PMRF.
By pursuing BTech.
And BTech, that also where you are doing in a BTech, that institute it want to recommend for PMRF. Okay, then only you are eligible for the direct PMRF.
It means I have completed the BTech. Then at this time I am not eligible for PMRF.
No, it is not eligible, sir. When you are in a final year, you have to apply for PMRF,
Okay, okay.
and then only it will be in a direct it is.
So, sir, with the score 467, can I get any good college for MTech,
Yeah, you can
like
get.
NIT?
Yeah, you can get NIT. You have to cross nearly 50 after. When the department is mechanical, right? Mechanical.
Yes, yes,
Yeah,
sir.
then if you have to cross 50, then in NIT Trichy you have to cross 50. The other NIT you can able to get. Depends upon your reservation also you can able to get.
Okay, okay,
Now they are giving us stipend also nearly 12,000 they are giving, right?
okay.
For stipend. After then we can apply for PMRF also.
So,
In MTech,
thank you, sir. Thank you.
MTech also we can apply for direct. From MTech also we can apply.
Okay, sir.
For,
Okay, sir.
for MTech, from the MTech only we can apply for direct PMRF. That also, that institute where we are going to join the institute, right? It should be in IIT. In all IIT, the PMRF eligible, okay. But NIT, only few of them is eligible for PMRF. Okay.
Means some top NIT.
Yeah, which are all top NIR of 25.
Okay,
Okay, which are all the top rank of NIT, NIR of 25, we can able to apply for PMRF. They are eligible for PMRF.
right, right.
Okay.
Thank you very much, sir, for this valuable
Okay.
information.
Thank you.
Hello, sir.
Yeah, tell me.
Sir, in NIT Trichy, one professor, NS Balaji, is there?
Name, sir? NS College in H department, sir.
NS Balaji Mechanical. Dr. NS Balaji.
Just now 1.5 year only before I joined as a PhD, sir. That also in the COVID pandemic it went there. I
Yeah,
will.
yeah, yeah.
So your name, sir? Your name?
Myself, Dr. P. Govindan from Milam Engineering College.
Okay, sir.
Yeah. So he's my friend. So he's working there as a ad hoc basis.
Okay, sir. Okay, sir.
Yeah. Let you know whether he's there in
Okay, sir. I will
NIT.
next class. Please, just to be the
Yeah.
conversations. I will tell you, sir.
Yes, thank you.
Okay, within 1 week I will meet you. Thank you.
Yeah.
Thank you. Okay, I'm going to wind up. Thank you.